Welcome to the GeoMethod channel. Today we are solving another interesting geometry problem. Here is today's challenge. Can you find the angles x and y? Take a moment to study the figure. Then let us uncover the key geometric ideas that make the solution click. Here is triangle ABC with its right angle sitting at vertex B. The two acute corners, A and C, hold the unknown angles we want. Call the angle at C the value x and the angle at A the value y. Our whole job is to pin down x and y from just two given numbers. The three angles of triangle ABC always add to 180 degrees, and the right angle at B already uses 90 of them. Subtract that 90 from both sides, and the two acute angles x and y must together make 90 degrees. They are complementary, which we will lean on at the end. We are told x is smaller than y. Since the pair splits 90, x has to fall below their even share of 45 degrees. Keep that in mind. It settles a choice later. Now the measurements. The side AC measures 8, and the area of triangle ABC is also 8 square units. Those two 8s are everything we get. Because segment AC sits opposite the right angle at B, it is the hypotenuse. The other two sides, segment AB and segment BC, are the legs that we will express through the angle X. Look at the triangle from angle C. The leg segment BC lies right against that angle, so it is the adjacent side equal to 8 cosine x. The leg segment AB faces angle C from across the triangle, so it is the opposite side equal to 8 sine x. Both legs now ride on the hypotenuse 8 and the single angle x. The two legs meet at the right angle B, so they are perpendicular. That lets one leg be the base and the other the height, giving area 1/2 times segment BC times segment AB. Substitute the leg lengths we found. The area becomes 1/2 times 8 cosine x times 8 sine x. Our first insight is this. Gather the numbers first. 1/2 of 8 times 8 is 32, so the area simplifies to 32 sine x cosine x. Here the double angle identity helps. 2 sine x cosine x is exactly sine of 2x, a single cleaner angle to work with. Rewrite 32 sine x cosine x as 16 times 2 sine x cosine x, then fold the pair into 16 sine of 2x. Now set this equal to the given area. 16 sine of 2x equals 8, and every unknown is packed into that one double angle, 2x. Divide both sides by 16. Sine of 2x equals 1/2, a value we recognize at once. Between 0 and 180 degrees, sine equals 1/2 at two places, 30 degrees and 150 degrees. So 2x is one of those two. Second insight now finishes the structure. The allowed range keeps 2x on the acute branch, so the valid choice is 2x equals 30 degrees. Have 30 and x equals 15 degrees. That is the smaller acute angle sitting at vertex C. Since x and y complete 90 degrees, y is 90 minus 15, which is 75 degrees, the angle at vertex A, and 15 is indeed less than 75, so the condition x smaller than y is honored. The angles are consistent. Let us confirm the area a second way. Drop a perpendicular from B straight onto the hypotenuse segment AC, and mark the foot where it lands as a new point H. Then draw that altitude, the segment BH, meeting segment AC at a right angle. The altitude to the hypotenuse equals the product of the legs divided by the hypotenuse. That is 8 sine x times 8 cosine x over 8. which reduces to 4 sine of 2x, and 4 times 1/2 is 2. The altitude cuts triangle ABC into 2 right triangles. Here is the top piece, triangle ABH, standing on base segment AH, with height segment HB equal to 2. And here is the bottom piece, triangle HBC, sharing the same height 2. Their bases along the hypotenuse add back to 8, so together they give 1/2 times 8 times 2, which is 8. The area checks out. So the answer is x equals 15 degrees and y equals 75 degrees. The final answer is x equals 15, circ, y equals 75, circ. If you found another construction, share the key move in the comments. Thanks for exploring geometry with GeoMethod.